Hi, this is ET370 Lab 5, and today we're going to talk about Neopixels. Neopixels are these really cool RGB LEDs. So here's a picture of a Neopixel right here. And before we're going to get these running in Tinkercad, we're going to talk about modulus and arrays. And so these are going to be nice Arduino tools that are going to help us get the code for these Neopixels understood. We'll also talk about how to install the library for Neopixel. This might be common for a lot of your projects. And we'll figure out how to get get rainbow colors to show up and to get that rainbow color to kind of move around. So I hope this is a fun lab. Okay, so let's start out with arrays. So arrays, I want you to think of like variables that can hold multiple values, all right? And so an empty array can be declared like this. So you have to declare a data type with all variables, right? Now this array here, I'm just giving it an array name, but to tell the difference between an array and a variable, you put these hard brackets, okay? Now here's an array with multiple values. In fact, there's 8 elements and you just put the number 8 in there. Very simple, right? And this data type can be int, byte, float, anything you want, all right? Now here's an example of filling an array with 8 random variables, and you can put a comma separated list here enclosed by curly brackets, right? Now, if you put an 8 here, which is exactly the number of elements, and if you don't put exactly 8 elements, let's double check. 1, 2, 3, 4, 5, 6, 7, 8. If you don't put 8, Arduino is going to complain. And that actually can be a good thing, right? That's like a check. So for example, if you knew you wanted to put 8 elements and you forgot, you put in 7, you accidentally missed one. When you hit compile, Arduino is going to complain and remind you, hey, don't you need 8? And that's a good thing, right? Now, if you just want to be willy-nilly, whatever, you don't have to put in the number 8, but it won't have that check. So you can define either or, right? All right. Now, one thing to remember is that when we want to access these values in this array, we're going to do so with starting with the number of 0. Okay, so the number 0 is corresponding to this 23. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so 0 through 7. And if I want the second 0, 1, 2, that's going to be 11 right here, right? If I actually want truly the second, then I'm going to have 1, right, for 68, 8, 0, 1, okay? So let's do an example here. So I want you guys to type this in. I already have it typed in, but let me pull up the code here. So I actually have the code. Let me bump this over so you guys can see it. I have the code here, and I basically copied this, and it's a little bit bigger here. So let's look at the left side. I'm declaring this array with 8 elements. It's the same set of numbers here, and I'm using the variable type byte. Byte is 8 bits, and so the largest number in decimal is going to be 255. You've seen this before in duty cycle for analog write, so none of my numbers are greater than 255. Good. And I'm going to declare an index variable with the value 2. I'm going to set up the COM port, and now I'm going to grab out and I'm going to replace array of 2 with the value 99. So that means I'm going to go in here and 0, 1, 2. I'm going to replace this 11 with 99. Now look at this one. I'm going to say array of I plus 4, which in this case would be 6, and I'm going to replace it with 38. So what's 0, 1, 2, 3, 4, 5, 6? So that means the number 102 here is going to be replaced with 38. And now here I'm laboriously going to print everything 0 through 7, 8 elements. And looky, we have a infinite while loop. Because remember from last week, a while loop with a statement that's always true is just going to stay in that loop. So this is just going to print these 8 values and hang there. Okay, let's see what happens. So I hit start. And what do we get? 23, 68, 99, not 11, 2, 0, 55, 38, not 102, good, and 72. So I hope this shows you how you can declare an array, how you can update values in the array, and how you can access different values in the array and print them out. Okay, so something you got to be careful of is when you access values in an array, you need to stay within the indices. So if you ask for example, X array of 10, you're trying to access memory, some random piece of memory that's maybe sitting next to this in the registers in the bowels of Arduino, but it's going to give you garbage. So make sure that your indices are within the expected length of your array. Okay. Actually, even more dangerous potentially is if you try to write data, write to values outside this, you could be really messing something up, right? Okay, let's keep going. So I'm going to stop simulation here. Now, if you notice here, this is kind of annoying, like having to print all this out. Okay. This is only for 8. What if I had 100 values in my array, right? Is there a way to print all this out elegantly with only a few lines of code? And there sure is. Don't forget the for loop that we learned about last week. And so what we can do is just wipe this whole thing out and replace it with a for loop that I have written here, right? So what is this for loop doing? For index equals 0, index less than 8, index plus plus, or index equals index plus 1. Remember, that's the same thing. And I'm going to print it. So I'll just type it in here. For int index equals 0, semicolon. Index is less than 8, so that means 7. Index plus plus, okay? Parenthesis, curly bracket, and then what am I going to put in here? Serial.println x array of index. And notice I'm putting the hard brackets, parenthesis close, right? So I've created a for loop, and this for loop is going to cycle how many times? 8 total times with the numbers 0 through 7, right? And it's going to print all these values out. Now notice I deleted this part, so nothing's going to get replaced, right? So let's just run this. And what I should see here, actually, let me clear it just so that you can see. 23, 68, 11, 2, 0, 55, 102, 72. Good. And so it's printing every value of the array. And notice I did it in 3 lines of code instead of 8 lines of code. And really, it's just a fixed 3 lines of code. If there were more values in this array, it would just require these 3. And you just have to change this final number here. Pretty sweet. Okay, so here's a very nice example of where for loops and arrays play well together. Okay, let's keep moving. So let's talk about this other thing called modulus. All right, and this will also come up in our Neopixel code. And the modulus operator uses the % key. All right. An easy way to think of the modulus operator is the remainder when dividing 2 numbers. So let's say you have 5 divided by 2. What's the remainder? Well, 2 goes into 5 twice, so that's 4, right? But there's 1 left over. Okay, and what we call the 5 is, it's called the dividend, and 2 is the divisor. Now, I don't expect you to remember that. I had to look it up right before we wrote this lab. But yeah, 5 is the dividend, 2 is the divisor, right? Okay, so what we're going to do is have you type this following code in. I've declared the remainder, dividend, and divisor as 5 and 2. Set up this COM port, and I did this modulus. So remainder equals dividend modulus divisor. All right. Now what am I printing? I'm actually printing out the sentence here, okay? So 5 divided by 2 has a remainder of 1, right? I'm literally printing that sentence. So let's go over here. I actually, again, have this coded for y'all. So I can hit the code here, and I have everything implemented. So I have the remainder, dividend, modulus, divisor. So let's just run this, okay? So I'll clear that. Actually, I had it from a previous run. Hit run, and boom, 5 divided by 2 is the remainder 1. Okay. So we can play with different values. What if we do 5 divided by 3? Let's try it. If we do 5 divided by 3, what's the remainder? Remainder should be 2 because 3 only goes into 5 once. So the remainder is 2. Let's check it out. Yep. Okay. What if I do, I don't know, 5? 5 divided by 5, what's the remainder? Should be 0, right? Yep, has a remainder of 0. So you can play with different values here and see that it's consistent with your understanding of a remainder, right? So that's all it is. It's just a remainder, folks. Okay, now some things to note. The dividend, okay, has to be an integer. The divisor has to be an integer, but also non-zero, okay? So this has to be non-zero, right? That you can't have something divide by 0. That's not happy. Okay, and then if the dividend is negative, though, the remainder will be negative. So it can handle negative values for this guy, right? Okay, so that's modulus, right? Now, what if we want to, what's the use of modulus? So it's like, okay, remainder, but now what, right? Who cares? Well, what I want you guys to think of as a useful application of the modulus operator is the rollover function, or a rollover function. So for example, this code here, notice I changed the value of dividend to 0. So I'm going to make this 0 and I'm going to make this 12. Okay. All right. And what I'm going to do is right above this remainder, I'm going to put dividend equals dividend plus 1. We know what that does. Every time it goes through this loop, it's going to add dividend, not dividend, dividend, come on, dividend. Okay, and I'm going to delete this while loop here, so I don't have this breaking and holding right there. This is now going to be allowed to loop over and over and over and over again. Okay, what we expect to see is that the dividend is going to grow 0, 1, 2, 3, 4, so on and so forth, right, forever. But the remainder here is only going to be bounded from 0 to 11. It's going to be rolled over. Once the dividend goes past 11, then the remainder is going to roll over. And you'll see that on the screen here. So start simulation. Okay, look at this. See how the 12 stays constant, right? The divisor is staying constant, right? But look at the remainder. Look how the remainder goes from 0 to 11, even though the dividend is growing, right? That's nice. That's like a rollover feature, okay? So you could think of it as like maybe degrees, like if you have an encoder, right? Where your encoder count is going up and up and up, but then this is only going from 0 to 360 degrees, right? Something like that, okay? So this is, I really want you to think of the modulus in two ways. One is a remainder and one is a rollover function, okay? So again, this concept will be useful later on in the Neopixels. Okay, so what did we cover so far? Arrays, multiple containers here, right? With a for loop, access to be able to read and write this very quickly. We have the modulus with the with what you call the remainder and also the rollover. Okay, now let's get to the meat of this lab. This is the fun part. And this is RGB Neopixel LEDs, really cool stuff. And I don't know if you remember from art class, but if you have 3 primary colors, you can mix them and get any color you want. And in this case, RGB are a set of primary colors. Now, the idea is you can send 3 different duty cycle values between 0 and 255 to each LED in here and get these unique colors. It's really cool, okay? And they come in single pixels, long strips, and even matrices. So I know a lot of projects that you guys might want to do have these, right? A lot of past projects and hopefully a lot of future projects will have them. Really cool stuff, okay? So you guys will be using this ring, but other labs might be using a strip, both really cool. And here's an example of the color code, right? This is the colors of the rainbow. I mean, you look at Rgb, see ROYGBIV, or you can have this one, violet, indigo, blue, green, yellow, orange, red, doesn't matter, right? But you can see these are the colors of the rainbow. Now, notice these are the RGB values. These would be the corresponding duty cycles in decimal, base 10. Okay, so let's look at blue. That's easy. RGB, red, green, blue. Look at this. The blue value gets a maximum number of 255. Whereas in green, the green value gets a maximum value of 255, right? What's yellow? Well, yellow looks like RG. Looks like yellow is a combination of red and green, right? So you can see that these mixtures will give you the color description shown here. Now, what's this column here? This is hex code. And so hex code, let me expand this out and let me kind of move this in. So what's hex code? And I'm gonna just, yeah, there we go. Hex code is a numbering system and it's base 10. And what's nice about hex is that you can now take an 8-bit number, 0 to 255 in base 10, and represent it with 2 hex digits. So that means base 10 or decimal going from 0 through 15 would be the equivalent of hex going from 0 to 9 and A through F. Does that make sense? A through F. A being 10, 11, B being 11, F being all the way to 15. So that means 11 in decimal is the same as 0B in hex, right? A would be 10, 11 is B. Okay, now we'll learn this later on, but the decimal number for 255 or a full 8-bit is FF. And you can see that here. Look at this. 255, 255, 0, FF, 0, 0. Okay. And you can go to this online calculator and verify. Just click this guy. Let's see. Will this allow us? Yep. So let's try it. 255. Let's convert here. Boom. FF. And you can try any of these. What is this? Let's see. What do we got here? 75. Let's try 75 here. So 75. Okay, hit convert. And what do you get? 4B. right? That's the hex one. Look at that, 4B, good, okay? We'll learn more about this in a later lecture, but I just want to give you a heads up that this is something you might see, especially in digital communication, right? Hexadecimal is just a very common way to represent, another way to represent numbers. Okay, but let's keep going with these fun Neopixels. What we're going to have you do is connect this in your Tinkercad. So you got a Neopixel ring with 12 LEDs, right? And you need 3 connections: ground, 5 volts, and then a signal. And we're going to connect DIN, the digital in pin from the Neopixel. It's either DI or DIN, through a 470 ohm resistor. Now, you guys in your kits might have a 330 and 100. You can add those together. That's pretty close enough. But you can go and put in a 470 ohm resistor. And what you really got to be careful is when you physically are using yours, you always want to connect and disconnect your ground last. So always ground in first and ground disconnects last. Okay, so ground in first, ground. So that way you don't damage the Neopixel. Okay, all right. Now, if you are powering more than 12, really should be more than 8, you don't want to use Arduino's 5 volts. You want to use an external 5 volt power supply and put a capacitor here, right? That's going to smooth out the voltage because it's going to get a little choppy. Still keep the 470 ohm, but yeah, you don't want to be using the Arduino. With 12, we can get away with it, but any more, you don't. You want to be using an external one, okay? Now, how is this going to work? What we're going to do is we're going to have to install the Neopixel library from Adafruit, okay? So how do we do that? So we're going to go to the library manager. We're going to go to Sketch, Include Libraries, and Manage Libraries. And this is not in Tinkercad. This is actually on your regular Arduino. Okay, so Sketch, okay, where are we going? Include Library, Manage Libraries here, okay? And what should pop up is this window right here. And what you're going to type in is, once it loads, updating all the list of installed libraries, you're going to type in Neopixel. Okay. And when you type in Neopixel, you can see I already have them installed, but there's Neopixel here, just the regular one, and then the matrix. Install both of them. Okay. Now you might not need the matrix, but definitely the Neopixel you will need. The Neopixel matrix, if you're going to use a matrix in your projects or a future project, install it. But at least this Neopixel, you will need that, okay? Okay, so now that you're there, you should be able to go to File, Examples, and scroll all the way down. Keep going here, okay? Let's go, come on, give it to me. So File, Examples, I'm gonna scroll all the way down. There it is, Neopixel, and we're gonna go to Simple, okay? Give you a minute to look at that. File, Examples, Adafruit, Neopixel, and Simple. We're going to open that bad boy. Okay, so we have this. Take this, and I actually already have it connected. So let me go and find the one where I have it connected. Was it this one? Yes, I have a blank one here. Notice I have my ring, power, ground, digital in, and these can be daisy chains. So there's actually a digital out here. So if I want even more Neopixels, I can daisy chain them, but we're just going to use this 12. Okay, I got my 470 ohm resistor and just a blank code here. Okay, so I'm going to take that simple code, Control A, Control C, and just bang, copy it in there. Okay, all right, I'm not done yet. What I have to do is I got to change this number of pixels from 16 to 12. Okay, now am I using pin 6? I am. Good. So 6, but I got to change this pixels to number 12 because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Okay, if you got this running, got this in here, got this running, according to this, I think you should be able to just run it. So let's go back here and just run it, and you should see the LEDs light up. Beautiful. Okay. And so you can see sequentially we're on green. Okay. So now let's look at this code and let's see how this is working. So what do we got? We have the Neopixel library, pound include, and we have a .h file, right? Adafruit neopixel.h. Now you don't got to worry about this. This is for their Adafruit trinket kind of thing. So don't worry about that. But this one defined as pin 6, good. Here's the number of pixel, good. And this is kind of a way where you're setting up this pixels object. Okay, so this is how you get everything set up. Look at this number of pixels, the pin number and then some frequency stuff, I suppose. Okay. All right. So this is kind of like the servo object or the serial object. You just need to set that up. We have a delay value here. It's 500 milliseconds, half a second. And then the setup, we have this, not really much in the setup, so you can just ignore this, but this is the pixels.begin. So this pixels corresponds to that pixel object, okay? So, same with serial.begin or servo.attach, okay? Okay, now what's going on in the loop? It's clearing, turning all the colors off. And then what do we have? Looky, looky, it's a for loop. What is this for loop doing? It's going from I equals 0, it's incrementing +1 and going up to the number of pixels -1. So 0 to, in this case, 11, right? Because if that's 12, this is 12 here, it's going from 0 to 11. Okay, good, good. Okay, so then what is it doing? So it's calling pixels.setPixelColor. I, so this I is that I, which is going from 0 to 11 every time it goes through this little mini loop here. And then look at this, pixels.color 0, 150, what is that? Oh, it's RGB. RG, look, a non-zero is G value, and then B. So that means it's going to be green. And then it's going to show the colors, wait half a second, and then do the next one. If we run it, we're going to see this. Now, what would happen, ladies and gentlemen, if I put in 150 here? Okay, red and green. I think we talked about this. Does it make yellow? Yeah. Yes, it makes yellow. Very cool. Look at that. So you can pick any color. In fact, why don't we go back to our chart and pick one of these colors here? What's interesting? So we did yellow already. Let's go with violet. 148, 0 to 11. Okay, 148. Let me bump this over. 148. Okay, 148. 0 and 211, and I'm going to hit run, and let me get this out of the way. And yes, sure enough, violet. Very cool, right? So right out of the gate, we're getting Neopixels to run. Notice the Tinkercad already had the Neopixel library loaded. This Tinkercad software is just amazing, beautiful thing. So I love it. Okay. All right. So let's keep moving on. So we got this working. We've connected the Neopixels. We got all this, the libraries installed. We've finished the 5th program. We've done the 6th program, right? So the 6th program is just playing with different colors. And now I wanted to explain what are some common commands here. So when you implement your real Neopixel, it might be a little bit bright. So you might want to go in the setup here and call this pixels.setBrightness. Okay, and that you can pick a number between 0 and 255. And I guarantee you the real pixels are super bright. So don't forget this, right? You're going to put that right in the setup here. I think after pixels.begin, and maybe a number like 50 might be good enough. Even that's pretty bright, right? So put that in there and it'll save your eyes. Okay. The other thing I want you to note is that this pixels.setColor, you can actually get away without having to put pixels.color, right? You can just straight up put the RGB value straight into this. So I believe this is a way, if you wanted to like declare this pixels.color first as an array, right? A color array first and then put it in. But I think it's it just makes it look a little messy, right? Why not just put the index and then the 3 values, right? This this extra pixels.color kind of makes it confusing. Okay, and so I kind of do that in the following code here. And then don't forget to put this pixels.show command. This is just setting the colors, but this is revealing the colors or illuminating, turning on the LEDs. Okay, so those are kind of the main controls you need to remember when using these Neopixels. All right, you have a begin at the setup, a brightness in the setup. You have a clear if you want to turn everything off, set pixel color, and then show. So don't forget that these two are kind of the big ones. All right. Okay. Now what we want to do is turn on the colors with different colors in the rainbow. Okay. So the other one was just purple or just yellow or just green. What if we want to make it like every color in the rainbow? All right. So we're going to go and declare above the setup 3 arrays just like this. And we're going to have a pixel index and a color index. Okay, so all the array stuff is coming back, right? That's why we had to talk about arrays at the beginning of this. Look at these multi-container arrays. So if you look at these numbers, 148.0 to 11, well, we know what 148.0 to 11 is. That's the violet. Then the indigo is 75.0.130, and then the blue is 0.0.255, right? So I hope you're seeing that this is the violet, indigo, blue, green, yellow, orange, red, all in a sequence right here, okay? So we're gonna take this and type it into your code here. So you can put that up in the setup, right? So put that here. I also want you to type in a pixel index and a color index. So put that in here right above your setup. Okay. Now in here in your loop, what I want you to do is get rid of pixels.clear here. And I want you to add this. So what are we doing here? In fact, you know what? I think I could get away with just doing it live. Let's do it live. Well, you know what? I don't want to type all this. I actually have it saved here. I'm a little lazy. Yes. Okay, good. I have it here. Whew. I have here all the color vectors in here. Good. And what do I got? Okay, I got rid of that that silly clear. And look at this. I have a for loop and I replaced it with pixel index. You see that? So if I go to the previous one, what did I have? I had I, right? So I replaced I with pixel index. I still have this, but I modified it. Now look how I modified it. I got rid of that color, but look at this. I have RB array of color index, RB array G. So RB array, rainbow array red, rainbow array green, rainbow array blue of color index. Okay, so color index is going to increment. Now, the problem is I only have how many colors? 1, 2, 3, 4, 5, 6, 7. I only have 7 colors, but I have 12 neopixels, right? So check this out. I can make color index the same as pixel index, but I can do a rollover modulus, right? I can use my modulus. Color index modulus 7. So that way when color index here becomes 8, I overwrite it to be 0. So it rolls over, remember that? So that's why we have the modulus. So that way this color index is going to go 0 through 7, then 0 through whatever's remaining, okay? All right, so that's it for this, but let's see it run. Ooh, pretty rainbow colors, yay, right? So it fills the matrix and then that's it, okay? Pretty neat, right? Nifty, okay? All right, good, good. And so just to remind ourselves, the pixel index is going from 0 to 12, but the color index is going from 0 to 7, starting over, and then, or 0 to 6, sorry, starting over, and then it's 0, 1, 2, 3, 4, so on and so forth until we're done with the for loop, okay? All right, good. So let's see, what's the next one? Okay, the next one is the last one in the 8th program. Okay, this is the one where I want you to think a little bit, right? This is the last program, and this is where you're gonna have to, there's nothing new for the homework. The only thing about the homework is you're gonna have to implement the 8th program on your physical Arduino, right? But the 8th program, we want this pattern, this entire pattern here. Let me run this again. Boop, boop, boop. Okay, we want this thing to fill out quickly, and then we want it to rotate. In fact, actually, why don't I just show you? Watch this. We want it to do this. What? Can you see the entire rainbow pattern rotating counterclockwise? Yes, that's what we want you to implement. Oh my God, that's going to be tricky. Well, it's not too bad. I actually wrote out all the commands here. Actually, let me see. Can I run this and then you can see this while I'm explaining? Oh, it's so pretty. So pretty. Okay, it's even prettier on the real thing. It's really cool. So here's what you're going to have to do. You want to initialize a variable named factor to 0. Okay, and you can do that above the setup. Now in the for loop, what you're going to do is you're going to modify the color index to equal the pixel index plus a factor. Notice in this one, the color index just equals the pixel index. So you're going to have to add plus a factor there. Then what you want to do is you want to get these guys out of there. You want to cut these out and put them right after the for loop, right? And the reason why is because you want to show after you've cycled through the for loop, not as you're going through the for loop. This will update every time you're going through the for loop. You want to update it after you're outside the for loop. Okay. What else are you going to do? Well, if you have this factor in here, the very first time if it's 0, what's going to happen? It's just going to print the rainbow. But then what you want to do is you want to print the rainbow again, but shifted by 1, and print the rainbow again, shifted by 1. So your factor has to increment. So what you're going to do is outside the for loop, once it's done doing a complete rainbow appearance, you're going to increment factor. Is that right? Now, what's the problem with incrementing factor forever? Well, the problem with incrementing factor forever is that it's going to keep growing and you only have 12 pixels. So outside, you're going to have to increment factor, but also do another rollover like this. Oh my God, you're going to do a double rollover. What kind of nefarious professor would ask you to do this? Well, this one. Okay, so you're going to roll over after the number of pixels is reached, and then you will get this beautiful behavior. Okay, I'll let you decipher my English language kind of idea here, and we'll see if you can implement it, right? It'll be fun. Okay, here's some more resources. You can go to the Neopixel library page. You can go to the GitHub. There's some best practices. So check these out. Thank you to Adafruit and their wonderful work getting these out to the community. But I hope you learned a lot in this lab, and should be fun. Should be a lot of fun. All right, have a great day.